Hey guys, in this video we're going to be taking a look at a composition of transformations, and all a composition of transformations is more than one transformation of a geometric shape on a coordinate plane. And it can be any combinations of translations, reflections, rotations. You can even do dilations in there too, and we'll get to those later on. So if we're looking at these, we're using all the rules that we've worked with so far. So there's our reflections, there's our rotations, and then we can also still do the translations. And those are the original point xy is going to go to x plus or minus a number, comma, y plus or minus a number. Plus means you're going to be going right. Minus means you're going to be going left because we're traveling along the x-axis. Positive y plus the number is going to be going up, minus the number going to be going down. So it's just a matter of using all the rules that we've worked with so far together for one problem. So if we look at a couple examples, whenever you do the composition of transformations, you have to do them in order. If it's listed first, you have to do it first. If it's listed second, it's got to be done second. You can't mix and match in between. Okay, so looking at the first example that we have here, it says graph the image of triangle IJK after the following transformations. We've got a rotation 180 degrees clockwise around the origin, and then a translation of XY going to plus 9 minus 2. So if we remember, plus 9 means right 9, minus 2 means down 2. But remember what I said, whenever you do these composition of transformations, this has to be done first, this one has to be done second. So with these, with the rotation of 180, that's where you're going to have to use the rule. And in order to use the rule, you've got to write the points down. So if we're writing the points, we're looking at the original XY. So we've got I, J, K. So if we're looking at point I is 1411. J is 10.3. And K is 6.7. So we're going to want to take those points and use the rules that they give us on them. There's a couple different ways you can do these. Some people are able to just use the graph to translate and all of the different points and transform them where they need to go. Some people need to write down the points, and sometimes you need to do a mixture between moving on the graph and then also writing down the points to use the rule on the points. You just have to do whatever the problem's asking you to do. So for this one, we've got a rotation of 180 degrees. So with this one, you pretty much have to use the rule to be able to do this one. So we've got the original points, so our original XY points are going to go to, it says 180. So the rule is XY goes to the opposite of X, opposite of Y. So opposite, so this one's going to be I prime because it's our first new point. So the opposite of X is negative 14, opposite of Y is negative 11. Our J prime is going to be negative 10, negative 3, and then K prime is going to be negative 6, negative 7. So for graphing these, negative 14, negative 11, and that's I prime, J prime, negative 10, negative 3, negative 6, negative 7 is our K prime. So that looks like it's been taken and rotated 180 degrees. So for the next one, they want us to go right 9, down 2. So you could take each of these points and move them right 9 or down 2, and then you could also do the math for them too. If we do the math, we're going to take these original points X and Y. We're going to add 9 to all the x's and subtract 2 from all the y's. So negative 14 plus 9, this is going to be our I double prime. And that's how you tell the difference between the first time you move it and the second time you move it. First time you move it, it gets 1 prime. Second time you move it, it gets a double prime. So negative 14 plus 9 is negative 5. Negative 10 plus 9, J double prime. Negative 10 plus 9 is negative 1, K double prime. Negative 6 plus 9 is going to be a positive 3. So then we're going to take all of our y values, subtract 2 from them. So negative 11 minus 2 is going to be negative 13. Negative 3 minus 2 is going to be negative 5. And then negative 7 minus 2 is going to be negative 9. So those are our points. And I'm going to ignore the points that I have and move and translate it the right 9 and down 2 just as a way to double check and try and make sure that I've got the problem right. And that way, if the points that I've graphed have matched the points that we've translated right here, then we know we at least have a chance of getting them right. So this one says plus 9 minus 2. So there's the J double prime. K double prime. And I double prime. So if we double check things, we've got negative 5, negative 13, yep, negative 1, negative 5, yep, and then 3, negative 9, looks good. So the directions say to graph the image of triangle IJK after the following transformations. This is what the final answer would be that you would want to enter. It's just this one right there. All the rest is doing the work to show what the answer is. So this is one where you would have to do a mix between writing down the points to find some of the in-between points, and then you could either use the points to find the new points, or you could just do the translation, either or. Alrighty, looking at the next one. Graph the image of triangle TUV after the following glide reflection. And that's just a specific type of composition of transformations. You're just going to translate it, and then you're going to reflect it is all it is. So first it says it wants us to translate the points x, and there isn't a value here, so it's kind of like we have x plus 0. So that doesn't mean that means it's going to not move left or right at all. Or another way you can look at it is all the x values are going to stay the same, and then this one, y minus 7, it's going to go down 7. So this we got to translate first, reflect second. So if we do that, I'm going to take the original points and down 7. 1, 2, 3. So that's going to be our U prime. There's our T prime. There's our V prime. Just double checking the links there to make sure I got the links there, and because remember, when we move these, the sizes are going to stay exactly the same. Okay, so translation done. We moved it down 7. Now it needs to be reflected across the line x is equal to 4. So we need to find the spot on the graph where x is 4, and that's going to be on the x-axis. X-axis is 4. And if you look, there is absolutely no y in our equation. So whenever we draw our line, we have to draw our line so that it will never ever touch the y-axis. So we can't make our line like that, because then it'd definitely be going through the y-axis. So anywhere through here it's going to touch the y-axis and it's not going to work. The only way we can have a line that will never touch the y-axis is for it to be a perfectly vertical line. So that means our line of reflection is going to go through here. So when you do these, and you see how we took this one and then we moved it, and then we used this new image to translate or transform to get the next one, it's the same thing for these. Whenever you do these translations, you move or transformations, you're going to move them, and then you're going to use those points to move it the second time. You do not go back to that original first picture. So once you use those original points, they're done. They can't be used again. So then your focus becomes these points that you see right here. So we're going to take these points and we're going to reflect them across the line. X is equal to 4. And if you look, that point is on that line. So there's nowhere to reflect it. But we're still going to name it U double prime. That way people know that we've thought about it and we know it doesn't move. So then we're moving T. So we want to see how far away T prime is from our line of reflection. So it's 8 to the right. So our T double prime is going to be 8 to the left. There's our T double prime. And now V prime, we're going to reflect it. And this one was 8 to the right, so V double prime is going to be 8 to the left. So there's our V double prime. And if we connect our dots, there's triangle TUV after it's been transformed. And the answer that we would want to put down would be this one right there. All the rest is showing the work for how to get that. So there's your couple examples with a couple different types of transformations, and this order isn't the only one that you could have. It's not going to be just rotations and just translations, or just translations and then just reflections. They could take all of the rules that we've talked about, mix and match them any way they want to. So if they wanted to, they could do 2 sets of translations, or they could do an x-axis reflection and then a y is equal to x reflection, or a 180 rotation and a 270 rotation. It's whatever they want to do to mix and match to move those shapes. If you have any questions, be sure to write them down on your paper and ask when you get to class.